Good afternoon once again. This time around, we are Al Capps and myself, Bob Stademeyer. We're going to discuss the good and bad and of pre-scheduling with EOBTs. And once again, as if all the other briefings, we're going to certainly stress along the way here the importance of proper EOBTs and hopefully getting them right the first time and talking to friends and everyone else and trying to make sure that and your fellow airlines and make sure they're filing EOBTs and how the effect they can have on you, your airlines, and GA community and everyone else if we're not all participating and sending in proper EOBTs. So we'll know our future departure. The reason I have this, oh, I'm sorry. Could we go back one time, Robbie? Just wanted to show you real quick. Ironically, we picked, thank you. Ironically, we picked the 1 hour to that we don't have a lot of pre-scheduling going on. So I just wanted to show you this real quick over here. That and this is roughly how it's working. We do pre-scheduling to Atlanta and Charlotte. Now Al's going to talk here in a minute a little bit more about that. And I just wanted to point out, because we may not see any for the next hour, of that Atlanta aircraft had filed an EOBT, and 20 minutes before that EOBT, a APREC, an approval request, or a call for release, in this case, we call them APREC these days, was sent across to Atlanta Center for approval, and that would have happened way back up here. This is a test system, so you didn't see that they responded, but that arrow would show that the request was sent. And it would send it 20 minutes prior to the earliest off block time. And I just wanted to let you show that. The point here is that the tower controller does not send the request. The system itself is just automatically sending that request based off that EOBT. And obviously, the further in advance, I meant to ask Eric that last briefing because I'm not really sure, Eric from TFDM, how far in advance they plan to pre-schedule under TFDM, and I'm not sure that answer right now, but I'd like to find that out. But right now, we're doing it 20 minutes prior to the EOBT, and needless to say, if we're doing it 20 minutes prior, you certainly need to be correct with your EOBT request at that time in the overhead stream that soon, because it's roughly 40 minutes before departure, and that hopefully everyone around you has filed proper EOBTs also. So if this was an aircraft that had my EOBT that I was pre-scheduling, and all of a sudden, after I got my time, all of these aircraft jumped down in front of them, now my time's not going to be any good. And once I finally push back, I'm going to have to request a new time, things like that. So I just kind of wanted to point those out, that there's some of the aircraft that were getting the time, and now I'm going to let Al take it over for a bit.
Thank you, Professor Bob. Thanks. If we can flip back, please. And thanks for taking that target of opportunity, to show some of the existing APRECs and the live system right now. So the first few slides here, so what we're going to talk about today is pre-scheduling with these earliest off-block times. As was mentioned in this morning's panel, there's a lot more to the system than surface metering when you talk about the TFDM system. A big part of it is how are we going to use the goodness, if you will, of these really good predictions that come from the surface in other big NAS decision support systems like TBFM. So today, without TFDM times, there's a manual calculation that's provided by controllers across the NAS. And generally, that manual calculation is done in their head. They're very busy. It can be different from different people. They're working as hard as they can, to provide those, but typically they don't do that until the flight gets to the spot. And if you wait until the flight gets to the spot, it's kind of like making that dinner reservation late. You're going to have to wait. You're going to show up and I forgot to make a reservation. You're going to be waiting. But if we can be confident in the times that we pass along earlier, we can claim that overhead stream slot. You can essentially take that delay as a part of your normal progress of the flight, and then reduce delay, increase predictability, all the goodness that we're trying to get out of the system. In my opinion, pre-scheduling with EOBTs should be the foundation of the system going forward. You know, I mean, whether or not a site surface meters, well, there's a lot of things. You know, do you have enough gates available? Surface metering is a great capability. It'll save a lot of fuel, but this capability, there should be no argument that this kind of capability is needed across the NAS. So it's really important to us in these sessions to provide material that explains kind of how it works a little bit. So this is just a real quick summary, kind of a high-level summary. Flights out of Charlotte. We're using Charlotte as an example. It's just an example. About 1 in 10 flights are impacted by one of these constrained overhead stream challenges. But you talk about another site. I was just in the hallway talking about SFO and some of the construction that they're beginning there now. But at SFO, it's about 13% of flights that are impacted by this particular restriction. Now today, you don't really have access to a lot of that data. You know about edicts. For many years, you know, we've all had an opportunity to substitute edicts for a different time. Yeah, you don't have that ability over here with APREX. And, you know, so now that ability is kind of opening up, the data's made available. And so it's a real problem in the NAS. There's a real benefits pool here, if you will. And the EOBTs are a big part of the solution. So what the ATD-2 team did was looked at the latest TFDM requirements and talked to our TFDM colleagues and said, you know, what are you guys planning? Why don't you let us go ahead and take that for a test drive, see if it works. And so that's what we did. And we definitely learned some things in that process. And that's what we'll talk about today a little bit. First, if you can kind of understand this, then you can understand how the system works that Bob just described. And it all starts at an adaptable time period prior to departure. Right now we're using 20 minutes prior to departure. And Bob, to your question about how far in advance TFDM schedules, I think there's still some discussion on the TFDM side of the house. I don't know if anyone in the room can speak authoritatively for TFDM. But the last time I was engaged in one of their requirements meetings, there's a discussion about whether or not you can have like only a subset of flights that are providing EOBTs. Maybe they could get these earliest times. And the flights that aren't providing the EOBTs, maybe they wouldn't. But we ran into a problem with that operationally. That was not even feasible for us. Because in operations, when you reach out to get a time from clearance delivery, everyone pretty much has to follow the same process. You know, there's a pre-departure message that's sent to those flights that are impacted by an APREC event at many sites across the NAS. You can't say, oh, if you're departing and you have an EOBT, please call me. If you're departing and you don't, please don't. So that whole concept of certain flights being subject to this restriction and others not, this didn't play out operationally for us. So instead, what we had to think about was, okay, so we essentially have to schedule everyone if we're going to pre-schedule at all. And so given that, and given that kind of in our DNA is do no harm, right? We have these ideas and, you know, we're trying to try them out in the field, but we definitely did not want to diminish the compliance. We did not want to diminish the benefits, right? And you'll see from some of Bob's slides here in a minute, that's, in fact, we're not seeing that. We're seeing benefit. But the only way we could get there was to schedule everybody at a certain time period ahead. And what I'm about to talk about is a buffer that essentially adds time. You know, if you provide an EOBT, you essentially have less padding or delay added to your time before it gets passed along to the TBFM system. Some people call this best equipped, best served. But what I would call it is necessary to do no harm. You know, and I'll speak about that in just a minute, what I mean by that. But okay, so the first step is the system for every flight 20 minutes prior to the best estimate of pushback generates a time, and it applies some buffer to that. It then sends that across to the TBFM system, and from that point, if I'm a user of if I'm a TMC on the TBFM system, it looks just like a request coming from the IDAC system. We did it in such a way that there wasn't a procedure change, but no matter how that's resolved on the center site, a time comes back over to the tower. And the cool thing here is it's not just the tower that sees that time. The ramp sees it immediately as well through the TTP swim feed. So it's available on the swim feed. So right now, at those airports where there is a TTP swim feed, if you want to know the restriction that your pilots and your flights are subject to, you can read them in from swim on a flight-specific basis and know exactly what ATC is looking at as well. Because what comes through swim is the same thing that the center sees, and it's the same thing that the tower sees. That's kind of the first time in the NAS we've done that, so that was a pretty interesting part of this. Then the IDAC style scheduling, people say, well, if I'm pre-scheduling everything, why do I need this IDAC red space, green space? Well, you need it because for any flight that's replanned, you know, I mean, all these things don't work out the way we hope, right? I mean, uncertainty happens, the NAS happens. And in those events, what we would like is an opportunity to find the best available slot. And that's what the red space, green space provides. Also, the accuracy requirements for EOBT, I mean, EOBTs are getting better. But recall, we're scheduling these flights 20 minutes prior to departure. So, and the requirements for getting to the spot at a designated time are plus or minus 5 minutes. So let's say you're a couple minutes early. You're out in the AMA for 7 minutes. What if a slot actually existed right now? You know, I mean, what I'm getting at is, even in the in-state NAS, when all these systems are rolled out, there's still enough uncertainty in the system that we need to be opportunistic and to, you know, find these opportunities here. And that's where the IDAC capability is key and remains key going forward in the future. So that's kind of the system that we have in place today. And there's a lot of steps here. I'm not going to go through them all. I'll leave them for you to read. And there's this, let's see, anything, Bob, on this slide that I haven't kind of already covered?
No, I don't think so.
Good question, Sterney. The buffer, this slide speaks to the buffer, and I will circle back to that question. So as I mentioned earlier, kind of the takeaway from this slide is that we saw the need for a buffer because there is a varying quality in the data. And for those groups that are working on their EOBT quality, and we have higher quality data, essentially, more accurate data, we know when the flight's going to push back. And from there, we add pushback is not an instantaneous event either. You know, the actual pushback duration changes based upon the tug. Some of these tug operators look like they used to work for NASCAR. They're really fast. Others are slower, right? Tugs break down. Ramp taxis are different. So much uncertainty in the system. But if the EOBT itself is not being provided, there's so much uncertainty, our ability to estimate when that flight would get to the end of the runway is not as good as it would be if you provided the EOBT. So that was the notion of where we added in this buffer. And right now at Charlotte, and this is only at Charlotte, not at DFW, where we also have the system running, if you provide an EOBT, then the system knows that, and it will only add 1 minute beyond your EOBT, and then the rest of the calculation is done to the end of the runway. That's the time that's passed along to TBFM. And Brian, I don't know if these numbers are still true. I think they are, right? Okay, all right. So there was a lot of calibration in the system. I mean, we didn't just come up with these numbers randomly. We looked at the uncertainty and in the data. And so if you don't provide an EOBT, then a 4-minute buffer is added to your time before it's passed along. Translating, you get a 3-minute advantage on the time that's passed along to TBFM if you provide an EOBT versus if you do not. And again, the reason we're doing that is not necessarily because we're huge proponents of best equipped, best served. It's because it is absolutely necessary to not diminish the performance of the facility. Now, your question, Mr. Sterncheck, was whether or not our decision tree or our ability is to break it out on a carrier-specific basis, and is that the nature of your question? Was like time of day and?
Yeah, I didn't know, like, I know that the NBAA, general aviation, you know, obviously they would fall under that EOBT would provide it or not. So that's how they would be paying, I guess, versus air carrier.
Yeah, we're pleasantly surprised and pleased with the quality of the data that we're getting from the general aviation community. And it's a big deal because these guys also take that slot. The slot is true for your entire airport. You know, it's similar to like an edict slot going into an airport, you know, and so if the general aviation operator provides an EOBT, then the notion is that they also would receive this benefit. You know, but I'm not quite sure we've gotten that. I mean, at Charlotte, there's only about 3% of the flights that are general aviation. Really kind of more excited about left field, where you see about 20%, you know, of the flights that are GA. Yes, sir. Joe? I can repeat your question.
With regard to the 4-minute buffer, you're providing an L time. I assume you're going to apply the 4-minute buffer to the L time?
It's a good question, Joe. So there have been some discussions in some circles as to whether L times and EOBTs are the same. And in some of the early SCT discussions, the Surface CDM team, there was an agreement that if you did not provide the EOBT, that the next in line would be to take the L time. And if the L time weren't there, we would use the original scheduled time. That's the way the algorithm works. However, in this case, the buffer, and correct me if I'm wrong, Mr. Phipps back there, but this EOBT buffer is only applied, and you get the lower time if it's an actual EOBT, not if it's an L time. They're the way the system works right now. Yeah.
Should you then be able to answer the question, how accurate is that L time?
Yep, and we can't answer that question. We can or we can't. I mean, we can answer the question, but what is your question, Joe?
I'd like to know how accurate specific L time from a carrier is compared to other carriers that are providing. How better the L time?
Okay. So I think,
I mean, if I'm more than 5 minutes off, I can understand. If I'm within 1 minute and hit me with another 3, we're going to talk.
yeah, okay. Order of magnitude, I think I can speak to that. There is a group within the FAA that is now responsible for measuring accuracy of EOBTs. And I think they're probably in a better position than NASA to address carrier-specific data, because we have partners, and to us, our relationship with our partners is more important than any one project or reporting data. So we're not going to go, you know, tell what. Yeah, but in order of magnitude, to get to your question, Joe, you know, so without L times, we're talking, you know, it could be 20 minutes of error in the P time, right, and pushback. With L times, we're talking, 20 minutes prior to departure. Order of magnitude of, so I just looked at some data recently, and I'm spitballing here a bit. But about 20 minutes prior to departure, and I'm being recorded at that. Wow, and the pressure's on. Yeah. No. So 20 minutes prior to departure, it's like this ramp, right? Of you can see the accuracy going down, and there comes a point at about within 5 minutes that it really doesn't seem to improve a lot. And in fact, you get some weird things close to departure that it's not always improving. But we're seeing, you know, L-time predictive accuracy of, say, a 10-minute sigma error, you know, plus or minus at 20 minutes out. So it could be the flight is 10 minutes early or 10 minutes late, you know, 20 minutes prior to departure. And remember, this is a 3-minute slot you're trying to hit at the end of the runway. 2 minutes early, 1 minute late. Yeah. And, you know, with EOBTs, just cut it in half. You know, I mean, it's like, it's amazing, you know. So to add a little bit of buffer on there, it's okay if the flight gets on the early side of it, right? And because especially if you have the IDAC-like capability, if we can err on the getting the flight out there a little bit early, we can make for sure it gets that slot. If it's out there early enough to get an earlier slot, we can hopefully identify it. And so, you know, both of these capabilities go hand in hand together. This is just pointing out that some of the questions we've had today is, what are the differences of ATD-2 and TFDM? This is an example of where we started with the TFDM requirements and we found a need to evolve it. And there's only one buffer in TFDM today. That might have changed since the last time I attended meetings. So they wouldn't have the ability to do what we did here without some changes to their requirements or to their functions. And we hope that they'll consider this as a change because we think it's pretty important. Right, there's one buffer called CTD, and it essentially serves the purpose of both EFTT and CTD. And so what CTD is like, if you wanted a way to tell all of the operators, hey, basically tell them push back a couple minutes early so that they make for sure they get to the spot on time, then that's what the CTD buffer is good for. But if there's varying quality on the incoming data, before you want to pass it along to TBFM, you're not going to necessarily want to do the same thing for all the operators, right? Because, you know, so by coupling those into one element, we felt the need to break it out into two. And it took a couple months to tweak these knobs, you know, because you've got taxi time prediction accuracy, you know, that you're tweaking as well, right? We had to kind of earn our way into doing this at the facility. We first came out to the site and we were like, our national NACA rep at the time was Pete Slattery. Many of you know him. He texted me today. He's retired now. But they were like, no. You guys need to show us that your taxi times are good enough, you know, before you can do this kind of stuff. So a lot of tweaking and calibration went on to it, but a lot of calibration on these knobs here too as well. Yes, sir. That's a great question, Dr. Phil. And that is something that we're concerned about. And, you know, NASA folks aren't the policymakers, but we also see these system-wide problems. And so determining how far in advance a site can pre-schedule is center level, maybe command center level kind of decisions, right? Because if every facility can just say, I'm going to allow, you know, the flights, every airport's going to want to pre-schedule like the day before, right? You know, at what point does it end? However, in general, I mean, so we'll show you some results here.
We're going to talk about that more at the end of the briefing here or later on.
And I think you guys probably don't need this. We actually had to win the opportunity to do this in the field. And so these slides were used for that, to try to help convince people this was a good idea to try it out on ATD-2's dime and time. And very thankful. Strong support from the TBFM program office, from A&G Next Gen office, from American Airlines, from Delta Airlines, and now United Airlines. So we're scheduling into Chicago now as well. All of those parties had to agree in order for this to allow us to do this. So really thankful for all that. But these were some of the slides we used for that purpose. And then Bob will take it away.
All right. Thank you.
Have you seen a lot of EOBTs come in that are within that 20-minute window, and is that a problem for the system?
Yeah, so updating the times after the 20 minutes, yeah, it's not a problem for the system. No, and you know, we've kind of learned. I feel like we've learned a lot in that area because initially, I think some on our team sent the signal that we didn't want updates beyond a certain point, and that was the wrong signal to send. Because if you know something on the operator side that is valuable, that could provide good data into the system, we want to have it. And on average, we're seeing, 12 to 15 updates per flight before departure, which is great. Because the back-end system can always ignore the data, right? But the back-end system can never get data after the fact. So if you have something that you think is a valuable update to the predictive accuracy of that flight, please send it. And this system will adjust, and in fact, it rewards you for doing so, as long as you do it before you push back. If you push back and now you say, here's my time, it's a little too late, yeah.
Yeah, as a matter of fact, for Chicago, since Chicago's not, we are pre-scheduling in Chicago, and that's not on APREC all the time. So there's many a times when they're like, okay, it's time to APREC Chicago, so they get turned on via the IDAC buttons. Now it shows up on the timeline, and if it's within the 20 minutes, it'll start, and they haven't pushed back yet, it'll start using whatever time was there, whether it was an EOBT or not, and start sending the request across. So since we didn't really get to see much of the pre-scheduled flights on the timeline live or anything like that, I do have some backup slides to just show you basically the process here along the way. So I just picked a flight, not sure when I did this, but what day I did it, but you get the general gist of it here. I kind of looked in advance. So here's a Delta, and by all means, this is the, if you've been in any of the other presentations this morning, this is the way Charlotte Tower, for the most part, all the TMCs watch one part of their display, the flight data portion of it, the flight table portion of it, and they keep an eye out for how these EOBTs are doing and things like that. Reference pushback, again, to fall back to what Al mentioned about, hey, are they trusting them or anything like that, and what the case is. So here's happens to be a Delta with the new EOBT at 2100. Right now, it's 20, 36, and 54 seconds. So since we're pre-scheduling 20 minutes before the EOBT, I expect that in roughly 4 minutes, that aircraft is going to automatically send a request over to Atlanta Center to get approved on the timeline. So I just happen to click on the aircraft to see what the red space, green space currently looks like. And you can see kind of red right around where it would be there. We show them on the timeline based on the EOBT when he would get out to the runway, and also the traffic around them. So here we go, and now it's now the time is 20:40, so the request is being sent over to Atlanta Center. This is so far up the timeline. It's roughly 40 minutes up the timeline, right? 20 minutes before the EOBT. A lot of times in busy periods, it's 20 minutes before the aircraft, by the time the aircraft pushes back to get to that runway in use, depending on which runway in use. So the tower TMC isn't paying much attention to this, doesn't really need to. The request is being sent across. Atlanta Center on their IDAC or on their TBFM arrival system is getting a little ding right now and a little color coding on their timeline. And it's just like somebody, they have no idea that a TMC or not sent this request across. So they'll go ahead and make the decision on the other end to approve the time or to move the time around to where it fits and then approve it. So now, here it is, a couple minutes later, and the time was approved, and it was approved for, looks like 21:16, roughly, and we have it, where are we at, the Delta? 1095, somewhere along here. Yeah, 21:16. And interestingly enough, right away it shows mustard yellow. So if, for those that haven't already known, that we give the tower TMC a little heads up, a little color coding. So if it's within that APREC window, if we're saying, hey, you're going to meet, his aircraft is right on time within that APREC window of 1 minute before to 2 minutes after the release time, we would show it but locked in green. If it's mustard yellow, that's what we're saying to them, hey, you're ahead of time, so why don't you take a peek, click on it at some point to see if you can get a better time, because we're going to show you and we went back and forth a couple times about this, but we decided to show them on the timeline where the aircraft actually can be at the runway. We back at the beginning, we forced it to stay at 2116, say, no, this is your time, this is where you got to come out at. But we found it better and a little bit more intuitive, and reminding that controller that this is where I can make it. Based on that EOBT, this is where I can make it to the runway, so I'm right at this moment, I'm early, okay? And of course, if you remember just a moment ago when I showed it was red space, that's why it got the time of 16 and not 14, because it was red space there, it just pushed it back, okay? So here's, we moved on a little bit. Oh, and that's what I'm showing you here, is just that the time it was red space there. That's why they got 16 on the way back, okay? But it's still, we're still going to say, hey, you're early. You know, you're ahead of that time, so you may want to check back a little bit later. Maybe it will be green. Maybe somebody else canceled out or something. You might be able to get that time. And I didn't say, but if we'd block it in red if the aircraft was running late, trying to remind them, better reach out and get a new time because you're not going to make this one. And here, I'm just pointing out that as we are at the time when we originally said the EOBT, when they were originally going to push back at 2100, where normal requests would be made when the aircraft's calling to push back. Take note, just in a general sense, that where before it was green pretty much all the way back, now there's more overhead slots have been taken, right? So, and this is starting to lead into your question there, Doctor, about are you picking winners or losers, you know, about who's getting the early time and who's not. And the answer under TFDM, if everybody's getting pre-scheduled and everybody's getting pre-scheduled early at the same amount of time, then everything cancels itself out, really. So I just wanted to point out that it is possible.
Bob, if I might add something to that.
Right.
So it may cancel itself out from the sense of, is the delay that you would get in the in-state NAS when everyone is pre-scheduling, let's say at 20 minutes, about the same. Where it doesn't cancel itself out is the predictability. And so what we've always been after is not necessarily changing the delay, because right now the delay, you'll see it go down in addition to the predictability getting better. Part of that is because, you know, the pre-scheduling window has changed a little bit. But when all of that demand is pushed out a little bit further, I mean, the thing is if you wait until the last moment, till you're at the spot, it creates so much additional uncertainty in the system from day to day. And it's that uncertainty that leads to eventually extended block times. It's extended block times that lead to flights getting to their arrival, you know, early, and then conflicting with other flights that need gates. So the systemic effect of the lack of predictability is all throughout our system. And in my opinion, it's things like this that are going to help reduce that.
Thanks, Al. And that I did have that in my head the whole time around along the way, as I thought, well, we're getting pre-scheduled here. I'm getting a better opportunity, which you can be. If you're the only one getting pre-scheduled, you can be getting a better opportunity at the overhead flow. And my point here along the way is, once again, you want to be right. You want to be right with that EOBT and not. And let's face it, a lot of the airlines have hubs, so a lot of your aircraft are scheduling into that same airport. And I think I mentioned it last briefing, I'll mention it again, that if all of a sudden they didn't make their time, their aircraft going to Atlanta, maybe out of Greensboro, and then Raleigh-Durham and Richmond, didn't get this time that they could have had if they put a proper EOBT in there. Go ahead. Accurate ones, right. That's very interesting.
Yeah, and if I might chime in on that, nothing necessarily wrong with that model, but just keep in mind what we're doing here is actually controversial, and one step maybe in that direction, because as of right now, there's in the system that will be coming out. To my knowledge, there's no way to actually give people benefits for providing an EOBT versus not. So even that is somewhat controversial, right? We're taking a step in that direction. Now, whether or not we then say, okay, some people's EOBTs are maybe like other people's L times, whereas some people's L times are like others' EOBTs, to your point there, Joe. It really depends on the level of technology that goes into producing those times. You can actually have really good L times, you know, that are high quality, and yet they don't go through the SWIM interface, and thus they're not an EOBT, right? So can we get to the point that we're measuring the quality of the data and then assigning a buffer associated with that? Maybe that's the right way to go. But this was kind of a step halfway in that direction, if you will. And so definitely no argument from us on the quality matters. Quality does matter, definitely.
Absolutely. And here's just a view of what the ramp would see along the way when that pre-scheduled aircraft gets scheduled before, and I don't have the Atlanta example over here, but beforehand just shows the word APREC on the data block, right? And then here's a different example. Well, let's follow through. Here's an example of an Atlanta that has the APREC time, that got the pre-scheduled time, and of course right away we're showing the amount of minutes you could sit there at the gate to hit that APREC and still get to the runway and hit that APREC time. So of course the number's fairly high because just not long ago the time went through. They got the pre-scheduled APREC time. So we're basing this 12 minutes, of course, based on their assigned EOBT and based on the APREC time they got back and the calculations of how long it's going to take out to get out to the runway. And over here is where the aircraft was allowed to push back, and then it switches over from the APREC time to that TMAT time. They're all different, of course, but I just got a few examples right there. It would show the TMAT time that in theory the ramp would try to shoot for to get out to the spot to help along the way to meet the APREC time at the end of the runway, or approval request time, departure time at the runway. So this is kind of my slide here that I threw together, and I know Al and I have had discussions about it one way or the other and things like that, and I agree with Al. It doesn't become inefficient, but I do want everybody to remember kind of what Al was saying is that it's not, because I know in my mind, maybe it's just me, but I think a lot of people, not just me, think about, oh, I'm getting pre-scheduled, I'm going to get a better time, because we think of those nationals to LaGuardia, those close-in airports are going to benefit from pre-scheduling. They may benefit it for more predictability, but they're not necessarily going to benefit by getting a better time, okay, along to your point.
It will until everyone, so imagine everyone in the NAS at every facility that's currently getting a slot now suddenly all have the ability to schedule 20 minutes prior. So essentially what happens at that point is we've just shifted the problem further out, right? We haven't changed anything. So unless someone like the command center or a center can weigh in and say, for those close-in airports that really have these really high, up to an hour tactical delay challenges, which happens. I mean, it can really cause challenges. Unless there's some bird's eye kind of governance that says, for these facilities, we're going to let them pre-schedule 30 minutes in advance. Whereas these folks that are further out, to prevent them from taking the slots of people that are earlier in, we're going to let them schedule 10 minutes in advance. Unless you do something like that strategically, I think we're still going to have the problem of the closer in flights, you know, that get higher, you know, higher times. And that's our concern is like, you know, there really does need to be, I think, that thought process going on with talking about how do you allocate tactical delay in the NAS. You know, similar to what's been done more strategically, right? But it does help with predictability. So I mean, I think from day to day, you know, if you're at one of those closer airports, you know, to the destination, and someone doesn't make the call and say, hey, this airport's closer in, it's a priority for us to get, you know, those flights off and reduce their high tactical delay. No one's done that. You're still going to see improvements in predictability, so long as the flight meets its pushback time and arrives to the spot on time and gets off on time, right?
That's correct. Yep. Okay. And this might go back again to what the doctor was mentioning, of called an end of the line pre-scheduling. And Robert, could we switch over to the other system real quick? Could we switch over to the other system just momentarily? So right here, could you turn the light down just a little bit for me there, please, Brian? So we can see what the point being here is. Let's look at the example of Charlotte up to the LaGuardia area, and basically Charlotte is the last destination that is being APREC'd, approval request, into the overhead flow into Washington Center's mile and trail system, right? So let's say that aircraft gets hit with a 25-minute delay, 25-minute delay. Well, in the interim, Jacksonville's down here, and there's a departure off Columbia and Myrtle Beach, and they schedule into the system, and they don't get as big of a delay. Maybe somebody off here, TYS, which I think is Knoxville, they get scheduled off, and maybe they don't get quite as big of a delay now, because they're scheduling in to the ARCs for the mile and trail for Jax, and this one's scheduling into the ARC for Atlanta Center, but Charlotte is the last one scheduling in to this flow into Washington Center's mile and trail. So this aircraft takes a 20-25-minute delay because of the overhead stream, and now these aircraft, since they're based on an ARC right here, end up departing right around the same time, and they're all tied up together. The integrated demand management with the that was with the overhead to potentially use a ground delay program type of situation, right? With everyone potentially. That would be more. I think that was focused more on the national to LaGuardia, leaving room for that national to get into the overhead stream. Okay, right. We can switch back, Robbie, please. I think we only have a few more minutes, 5 more minutes. Thank you. So, and that is in the case of a little bit of what we call that Goldilocks principle about when do you stop scheduling into the flow? When do we make it end where it becomes inefficient and you're starting to tie planes up, or you stop tying planes up? Do you want to schedule all the way to the West Coast or not? And inaccurate EOBTs, I believe I said it earlier, that you can waste slots in the overhead stream on your own if you're not accurate, right? I went through that scenario. Accurate EOBTs. Let's see. I think that for the most part, this was just a slide showing how a LaGuardia gets scheduled in. You can see how little green space there actually is for that aircraft. It's going to probably get the time right up around here, which it ends up, that's what it ends up getting. And then you can see on the TGUI timeline where it gets scheduled into, right? It took a fairly big delay, but it has to get scheduled after these aircraft because it's recognized in all the other aircraft that's airborne. And then the interim, exactly what happens, that Knoxville departure comes off and pushes that aircraft into a delay. So all of a sudden, that center, Washington Center, will be vectoring those planes for a few minutes, trying to fit them into the stream at some point, even though the American departed on time, within their APREC window. Still going to end up getting vectored because we have the Charlotte departure down here. It's going to end up being tied up with that Knoxville departure right there. So somewhere in here, there's going to be some vectoring going on. And then, Al, did you want to mention this on the way out?
Sure. Yeah, we're wrapping up here, right? So, this slide shows quite well the improvement in predictability. So it's not just a guess. We're actually seeing this in the data. And I would say this is the money shot down here. These are quartiles that we evaluated the variance of the times that come in from day to day, and in terms of minutes of delay, and we're seeing a significant reduction since we began this activity, which is excellent. That's what we wanted to see. Anything else, Bob?
Just this last one about Chicago.
Yep.
We started that in June.
Yep, still early in that work, but we were encouraged by the community reached out to us and said, hey, can we start this process you've been doing from Charlotte to Atlanta? Can we begin it from Charlotte to Chicago? And we're like, we'd love to, but we need to go check with everyone. And so the community was good with that, and so we started that recently, and we're still collecting data on it. Really want to do this into New York, but there are some challenges there. When a flight has both an APREC and an edict, I mean, life's hard. It gets really complicated. And tomorrow, in one of the sessions where we're bringing everybody together, I'll talk briefly about some of the work NASA hopes to do beyond ATD. One of the things we're contemplating, and we're asking for your input, is, how do we get stuff out of Bob's head? Bob knows where the delay's coming from, right? I mean, but when you're delayed by some event, where did the delay actually come from? I mean, we all have congestion, like, on our map, we're going from A to B, and we can see where the congestion is along the way. We know where the delay's occurring. We don't have that service, that tool available in the NAS today, right? And then when you're delayed and you have congestion, what options do you have? Knowing that this flight does or doesn't have a particular option, we can route around it, we can substitute it for another time, is also a really hard thing. So, we showed you one view of the data, but what we're starting to think about is there a simpler way to explain this to people on a flight-specific level, so we can just say that, hey, these 100 flights of, 600 flights at this facility had these options available to them at this time, and only 3 people exercised them, But anyway, it's kind of another way of looking at all this. I wanted to put a plug in for that tomorrow, and because if that's of interest to you guys, let us know. If it's not of interest, let us know.
Let me ask you one question online. I think our time will be up then. How was the 20-minute window chosen? Is there a sweet spot for EOBT accuracy ahead of D0 that help improve APREC compliance?
It's a great question. And Bob will tell you that we did not start with a 20-minute window. Crawl, walk, run is kind of our strategy. And so we incrementally increased it further out, but the EOBTs were evaluated to look at their quality at various look-ahead times. One of the other breakout sessions talks about how we measure EOBT quality. Sounds like it'd be a simple thing. From our experience, it wasn't as simple as we had hoped. And we're hoping that the work we've done there, okay, the work we've done on that, the community can use as a definition. But the quality of the EOBTs has just really improved over time, and we're really pleased with what we're seeing in that. And because that quality improved, we were able to move it all the way out to 20 minutes, which is pretty far out. If you think about some of the events that come in on a flight that might give you a better pushback time, like, hey, my passengers have started boarding. Like, hey, I'm now done with the fueling event. All of those happen within a 30-minute window prior to departure, right? So we're pretty happy to be able to schedule at 20 minutes and not only see no diminished compliance, but actually improve compliance, as well as a reduction in uncertainty. So that was a win-win for both ATC and the operator.
Very good, thank you. And I think we're wrapping up. We hit our time, but anybody's questions we didn't answer, Al and I will be around for a few minutes if anybody has any questions. Thank you very much.